Okay, in part 6 we're picking up moving the moist air parcel, and I'm going to continue moving this moist air parcel up parallel. We're going to move it parallel to the moist adiabat. Trying my best to keep it parallel. It's kind of difficult doing this on a mouse pad, but you get the idea. I'm going to continue to move it up. And so my air parcel is moving up into the atmosphere. Now, what we're going to do is we're going to compare some temperatures. See if I can get this off the... Okay, there's a little break there, but it should be a continuous line. Now, what we're going to do is let's compare temperatures at different levels of the atmosphere of the air parcel, which is indicated by this line that I have drawn in, and compare it to the temperature of the surrounding atmosphere. Recall, if the air parcel is warmer than the surrounding atmosphere, it will be lighter, more buoyant, and will continue to rise. And we know that from mountain sim, rising air eventually condenses, forms a cloud. Now, we said the bottom of the cloud was down here at about 900 millibars, or actually near 925, because that is where the dry adiabat, the dry air parcel, met with the saturation mixing ratio point from the dew point, and then we began to follow parallel to this moist adiabat. So this is where condensation took place, and now the air parcel is moist and continuing to move up in the atmosphere. So let's take a look at the temperature at 850 of the actual atmosphere, the environmental temperature at 850, and it's sitting right on the 0 isotherm. So the temperature of the surrounding air is 0 degrees. However, at 850, the temperature of the air parcel is about 5 degrees. So at that level, the air parcel's temperature is warmer, actually right here, is actually warmer than the surrounding air by about 5 degrees. So since the air parcel is warmer, it will continue to want to rise parallel to the moist adiabat here. And if we get up to 700 millibars, we compare the temperature of the air parcel. We move down parallel to the isotherms, and we see the temperature of the air parcel at 700 millibars is about -6. The temperature of the atmosphere is indicated by the red line. You see where I have the crosshairs. We go down here is -10. So at 700 millibars, the air parcel temperature at -6 is warmer than the surrounding air temperature at -10. So if the air parcel is warm, it will continue to rise. It's unstable. And in fact, if we come up to 500 millibars, the temperature of the air parcel is about -25. And the air temperature at 500 millibars of the surrounding atmosphere is right about -28. So the air parcel is still warmer than the surrounding air, so it continues to move upward. However, if we go up to about 475 millibars, the temperature of the atmosphere is about -28. The temperature of the air parcel is -30. So now the air parcel is cooler than the surrounding atmosphere at 475. So since it's cooler and heavier, it will want to fall back. So this is the top of the cloud, where the environmental temperature and the air parcel temperature are the same. So the cloud will be from 475 millibars down to about 925 in this particular example. We'll pick up in part 7.